Today we're diving into a high-stakes battle that's being fought in total silence, every single millisecond of every day. It's the digital arms race, and it's all about protecting our most valuable asset, our data.
I mean, just think about it for a second. Your entire digital life, every email, every bank transfer, every private message, it's all protected by a digital lock. But here's the thing about cybersecurity. No lock stays unbreakable forever. The people trying to pick those locks are always getting smarter.
And the sheer scale of what we're trying to protect, it's just staggering. We're not talking about simple text files anymore. This is a massive flood of incredibly complex information. High-res images, streaming video, sensitive data from our power grids and hospitals. It's literally the blueprint of our modern world.
So how in the world do we keep this global ocean of data safe? Well, the answer is encryption. It's like an invisible shield, this silent guardian that just scrambles all our information into unreadable code, making it totally useless to anyone who doesn't have the right key. It's the bedrock of all digital trust.
But what happens when that guardian starts to show some weakness? Let's take a look at the cracks that are starting to form in that shield. All right, so for more than 20 years, the heavyweight champion of encryption has been something called the Advanced Encryption Standard, or AES. It's the absolute gold standard. Governments use it, banks use it. It's in pretty much every secure system you can imagine. It has been our most trusted protector for a long time. But things are changing. New and really clever cracks are showing up in its armor. And these aren't your typical brute force attacks just guessing passwords. No, they're way more sophisticated. Take something like a power-based attack. It's wild. It doesn't even try to guess the key. Instead, an attacker carefully measures the tiny changes in a computer chip's power consumption while it's encrypting data. And believe it or not, those little fluctuations can actually leak information about the secret key. It's these kinds of sneaky side-channel threats that are starting to chip away at AES's dominance.
And look, this isn't just some far-off theoretical problem. The very patent we're looking at today spells it out. And I mean bluntly. The technology to break our current standard is getting better and cheaper, and we are fast approaching a point where AES just won't be enough. A replacement isn't just a nice-to-have, it's an absolute necessity. The clock is ticking.
So if the old lock is getting weaker, what does the new one look like? Let's dig into this proposed next generation of digital security.
And here it is. This patent lays out the blueprint for a whole new kind of lock. It's called DHOME, which is short for Double Hashing Operation Mode for encryption. And it's designed from the ground up as a direct answer to the weaknesses we just talked about.
So how does it work? Well, at its core, the idea is actually beautiful in its simplicity. If one lock isn't secure enough, then use two. DHOME uses two completely different mathematical functions, one right after the other. They're called hash functions. The best way to think of a hash function is like a one-way data blender. It's super easy to toss something in and blend it all up, but it's pretty much impossible to unblend it and get your original ingredients back.
Okay, so this diagram shows you the whole process from a bird's eye view. Now, it might look a little complex, but it all starts with a random number called a seed, which gets passed through this two-layer system to create the keys that ultimately lock down your data. Let's break that down step by step.
Here's how it all comes together. First, the system generates a nice long random number. That's the seed. That seed gets put through the first data blender, that first hash function. Then, the result of that gets put through a second, totally different hash function. And that's what creates the actual keys to encrypt your data. Only then is the file itself locked up. But here's the really clever part. The original little seed is encrypted separately and then stored right alongside the main data. And you're about to see why that's a total game changer.
See, this new method isn't just about being stronger. It's also a whole lot smarter, especially when it comes to the cloud.
So what makes this double lock system such an upgrade? Well, for starters, that two-step process is specifically designed to shut down those known attacks against AES. By layering the hashes, it creates what experts call confusion and diffusion, which basically just means it scrambles the relationship between the key and the final encrypted data so much that it's nearly impossible to reverse engineer. Plus, it's super flexible. It works with both the shared secret key and the public-private key systems we use today.
But the truly revolutionary part of this design isn't just about pure strength. It's about its incredible efficiency. And this solves one of the biggest headaches in modern data security.
This right here perfectly sums it up. Okay, imagine you've got a huge file in the cloud, maybe a terabyte of scientific research or video footage, and you need to share it with a new colleague. The old way, you'd have to decrypt and then re-encrypt that entire massive terabyte of data.
It's incredibly slow and computationally expensive. But with DHOME, you don't even touch the big file. You just re-encrypt that one tiny little seed we talked about. That's it. It's literally the difference between having to move a mountain and just moving a single pebble.
So, what does a new lock like this really mean for the future of our security?
You know, the big takeaway here is that this patent isn't just a clever new algorithm. It's a forward-thinking strategy. It's a blueprint designed for a world where our data is just getting bigger and more complex, where we need to share it instantly, and where the threats are constantly evolving. It's a plan for a much more agile and robust digital shield.
And that leaves us with a pretty crucial question. This patent, it represents one major leap forward in this constant cat-and-mouse game between the code makers and the code breakers. But with things like quantum computing just around the corner and a data universe that's expanding to unimaginable scales, you have to wonder, what new shields and what new weapons are waiting for us just over the horizon?